How we doing today? Shout out to the AP Calc class. How we doing? Today we're just gonna scratch the surface, get a little introduction into the second really big topic in AP Calculus, which is the derivative. The derivative is super important, and we need limits. We have to learn limits first, because in order to define a derivative and prove it from the beginning, we need limits. We eventually won't use limits to solve derivatives. We'll have other methods that are much easier. But I just want to show you where the derivative comes from today, so we can start practicing doing derivatives on day 7 and 8 and things like that. So why do we use derivatives? Derivatives help us to find slopes of tangent lines, right? We're all used to solving slopes on linear functions, right? If we have 2 points, we can do the change in y over the change in x. But what if it's not linear? What if it's a curved function? When we take a look at this curved function here, it would be really difficult to determine what is the slope of this function because it seems to be changing all the time throughout the entire graph. But calculus allows us to help find what we call an instantaneous rate of change, or instantaneous slope, or slope of a tangent line. Okay, those are all things that we think of with derivatives. So go ahead and jot that down. We can think of derivatives in terms of an instantaneous rate of change or a slope of a tangent line. We should remember from geometry class what a tangent line is. If I wanted to draw a tangent line on my graph at the point indicated right there, right? I want this tangent line to be linear, obviously, but to match the instantaneous slope of that curved function at that point. We can kind of think of it as a line that comes in and touches that at exactly that one place, kind of matching the slope. So I'm going to practice just drawing a few tangent lines here on different points, and I want you to practice drawing those tangent lines into your notebook. Okay, so I drew 3 different, my best approximation of tangent lines to that original curve. I also I want you to take a look at the original curve. In the future, I'll use different colors so you can tell them apart a little bit better. But of our original curved function here, I want you to see, does it appear anywhere on that curved function where a tangent line would have a slope of 0? So think about that, take a look at the picture, and try and find a point whose instantaneous or whose tangent line slope would be 0 or horizontal. I'll go ahead and draw it in a different color. As we can see, that blue line that I just drew, the tangent line there slope appears to be 0. To the left of that blue point, we can see that the slope of the tangent line there would be negative. To the 2 points to the right of the blue point, the tangent line slope are both positive. with a steeper slope on the point farthest to the right. So what we want to do now is figure out how could we come up with the slope of a tangent line. Okay, so what I want you to do is draw a new curve, draw it kind of big, just in your notes on the next page. And what I want to do is I want to figure out how am I going to be able to find a slope of a tangent line. Okay, so we can just put our xy axis over here. And make that go just a little bit farther here. Okay, so we have kind of a gentle curving function f of x here. And I'm just going to I'm going to plot a point on here that I'm going to try and find the slope of the tangent line at that point. So I went ahead and plotted that point. We're just going to call it x and the point x comma f of x. We'll just be very general here. And again, I want a tangent line. I'm going to draw the tangent line down in a different color. I'll use, I don't know, I'm colorblind. I'll figure it out. So this blue line here is our tangent line. And what I want to do is figure out the slope of that line. The only problem that I have is that I only know one point on the line. I know the point at x comma f of x. This point right here we're just going to call x comma f of x. So we run into an issue. Sorry, this board isn't working particularly well. We're getting a new one soon. But we're running into an issue where we're really good at finding slope when we're given 2 points. We just change the y over change in x. But how do we find a slope with only 1 point? Well, when we don't know how to do something in math, we go back to something we do know how to do. So what I'm going to do is I'm going to try and estimate the slope of this tangent line by drawing what's called a secant line, a line that's going to hit 2 points on this graph. Okay, so I'm going to pick another point to the right of x, right here. I'm going to choose this point to be a distance away, a certain distance away. I'm going to call that distance away, I'm going to call it h. So that other point is a distance h away from x. So what I'm going to do is I'm going to go ahead and name that point now. I'm going to call that new point x plus h. Its corresponding y value we would call f of x plus h. Now, if I wanted to find the slope connecting those 2 points, this is going to be really easy. So what I'm going to do is I'm going to draw a line that connects the 2 points, x comma f of x, and the other point, x plus h, comma f of x plus h. I'm going to draw a line that connects those 2 points. So this is called the secant line. If we notice, I want you to notice the difference between the slope of the secant line and the slope of the tangent line. Are they the same? Are they close? Well, we can clearly say that they're not the same slope. In this particular example, the secant line has a steeper slope than our tangent line slope. So I want to know, how could I make a little bit better of a secant line? How could I improve the accuracy of my secant line? Okay. Well, we could try, what if we chose a point farther away? Would that help? If we chose a point up here, well, if we choose a point up there, we're going to have an even more off slope. So we can just choose a point that's a little bit closer. Now, I want to stop for a second, and we can't find the slope of our tangent line yet, but let's take a look at what would be the slope of that secant line. Well, anytime we have 2 points, finding a slope is very simple. We do the change in y over the change in x. When we do that, right, I'm going to lead with my x plus h and my f of x plus h. Our slope would be f of x plus h minus f of x. If you want, you can think of this as like y2. You can think of this as like y1 over x plus h, our x2, minus our x1, which is x. So that quotient up there will be our slope of our secant line. F of x plus h minus f of x over x plus h minus x. But I want you to see, is there anything on the bottom of that slope that could be reduced? Could we clean that up a little bit and make it a little simpler? Well, if you take a look at the denominator there, we have x plus h minus x. What's going to happen to the x and the minus x? Well, those two things are going to cancel. And we can now say our slope is simply f of x plus h minus f of x over h. So that f of x plus h minus f of x over h is now the slope of this secant line that we chose. And what I want you to see here is, what we're going to do is we're going to try and choose 2 points that are a little bit closer together than they currently are. What if I shrunk the value of h to be a little bit smaller? I'm going to draw another secant line. This is going to get a little messy, so stay with me and take a look at this next line. So by choosing a point that's a little bit closer to my original x comma f of x point, by choosing a little bit closer of a line, we can see that this new red line, its slope is getting a little bit closer to our tangent line, right? It's a better approximation than the first secant line I drew. What if I chose a point even closer? What if I chose a point, again, now it's going to get really messy. Don't worry too much about it. I just want you to see the concept here. What if I chose a point right next to it, right here? Okay. Well, now my yellow line slope is really getting close to the slope of my tangent line. So what have I been doing with each successive secant line here? What have I been changing? Well, my points are still x comma f of x and x plus h comma f of x plus h. But what's happening is I'm letting that distance between those 2 points get smaller and smaller and smaller. Now, what if I put those 2 dots, what if I put x and x plus h right, like infinitesimally close to each other, right on top of each other? Well, if I did that, then I would get the exact slope of the tangent line. So what we have here is we want to shrink h to be really, really, really small. Now we know if they're the exact same point, if h actually equals 0, we look back to our slope formula up here and we see, oh, well, I can't divide by 0, it's undefined. Well, I end up with, actually, if I plug in 0 for h, I end up with 0 over 0. Now, think to yourself, what have we learned how to do in this class that deals with a problem of 0 over 0? The answer is our good friend, the limit. So, the derivative can be approximated by doing a limit as h goes to 0 of that secant line slope. Now I'm going to clean it up and I'm going to write our definition of a derivative down below this graph. So here's what it looks like. So you know, that symbol there, f prime of x, is shorthand notation for the derivative of the function f of x. So f prime of x is a notation that you'll be very comfortable with as we proceed through here. That just means the derivative of f. So f prime of x is defined as So f prime of x is defined equals the limit as h goes to 0 of f of x plus h minus f of x over h. So if you look up the definition of a derivative on Google, you'll see this formula. F prime of x equals limit h goes to 0 of f of x plus h minus f of x over h. Now most people, when they look at that, they have no idea where it came from. But you guys are different. We know by looking up here that that formula, f of x plus h minus f of x over h, is simply the slope of a secant line. But we're just letting those points on the secant line keep getting closer and closer and closer to our regular x value. This will give us the approximation of the slope of the tangent line, which is going to be hugely important for us through the rest of this class. Enjoy. I'll see you guys tomorrow.